So I'm going to go through an example of the LAD linear regression. So in this problem here, we're given 5 points in the plane, and we're going to try and find the line that best approximates them. So the question says plot the points, work out which pair satisfies the condition that the line going through that pair splits the 5 points up into half on or above and half on or below. And then for those lines, calculate the sum of the absolute values of the distances from the points to the line, and then find the line that gives you the smallest result. So here are the 5 points plotted. So there's 3 in a row here, and then 2 sticking outside. The points. Let's look at the lines that satisfy the given conditions. So if you look at P1, P2, this dotted line here, you can see that the number of points on or below this line is only 2, and it's got to be at least half on or below and on or above. So this line here isn't one of the allowed lines, and neither is P4, P5 for the same reason, and neither is P1, P5. So the only possible lines are P1, P3. You see it's got 3 points on or below and in fact 4 points on or above. P1, P4, P2, P5. You see these lines are splitting into half the points are above, half the points are below, roughly. P3, P5, and the line that goes straight across P2, P3, P4. We're interested in the lines here. I mean, there's really 3 pairs here, P2, P3, P2, P4, P3, P4, but it's just a single line, and it's only the line we're interested in. Okay, now what we do is we calculate the distances from the points to the 5 different lines. So here we've got P1, P3, that's this red line going through P1 and P3, and we need to determine the distances of the other points to this line. So that's this distance plus this distance plus this distance. And sometimes you can just read it straight off the picture. In this case, it's pretty obviously 1 plus 2 plus 3 is 5. But a more straightforward way of doing it is first of all find the equation for the line, and then substitute that equation into the formula for the distance. So to get the equation for the line, it's just first of all you work out the gradient. So between our 2 given points, the rise is -2, the run is 2, 2 over 2 is 1, so the gradient here is -1, and then you just have to think what constant term do you add in so that when you substitute in the first point, you get the right y value of 3. So when x is 1, y should be 3, so the constant term has to be 4. And then once you've got this formula, you just substitute in then the different values. For P2, x is 2, for P4, x is 4, and for P5, x is 5. Plug it in and you work out the d distance. Okay, so that's for P1, P3. P1, P4, looking a little bit more complicated, but it's exactly the same idea. We work out here the distance, the x distance between P1 and P4 is 3, and the change in y value is 2, so the gradient is -2 on 3. In order for P1 to have y value 3, we need the constant to be 11 on 3, because 11 on 3 minus 2 on 3 is 9 on 3, which is 3. So that's our formula, and then we just substitute in. We substitute in x is 2, so this is the y value minus the y value of P2. Then the y value at the point x is 3, that's this height, minus the y value of P3, which is 1, plus the y value at x equals 5, which is just this little height here, minus the y value of P5, which is 2. In each case, we take the absolute value. And then you just work out these numbers. You find that you'll get 4/3, 2/3, 5/3. Add it all up, it's 11/3. Okay, now we've done the first two. We've got 3 more to do. P2, P5, that's this one. P2, P5. We work out its equation. So this time it's going up 1 over 3. So the gradient is positive 1/3. When x is 2, we want y to be 1. So when we substitute 2 in here, 2/3 we'll need to add on 1/3. So the constant is 1/3. We just plug that into the formula. This time we're plugging in x is 1, x is 3, and x is 4. That gives us these three terms. We add them up, and this time we find it's 10 on 3. We're looking for the smallest one. So far we started with 5, then 11/3, now 10/3. So this is the smallest one so far. Then we do P3, P5. P3, P5. It's got this equation here. The gradient here is a half. You see it's going up 1 over 2. And you just need to see that when x is 3, we should have a y value of 1. And that forces the constant to be negative a half. Substitute in, we get d is 4. So this has actually got worse. And then the last one is this one along the bottom. Now this is really simple. This is just y equals 1 is the equation, and the distances are 2 plus 1 is 3. And that is the smallest number so far. That's the smallest number, so that is the line we're looking for. This green line, P2, P3, P4, is the ladder regression line. Now, in this particular case, it turned out to be the one that went through 3 points. Sometimes it is, sometimes it isn't. You can't really tell usually until you do the calculations. But anyway, that's what it is in this particular case.